Dear students, so in this session we are going to talk about phosphorus trichloride, halide of phosphorus. It can be prepared by the reaction of phosphorus with chlorine. Of course, slow stream of chlorine has to be passed over white phosphorus so that it becomes phosphorus trichloride PCL3. Usually phosphorus is represented as P4, therefore 4PCL3. 4 into 3, 12, 6Cl2. So reaction of phosphorus, that is slow stream of chlorine, it should not be in excess, that is the meaning. You will be getting phosphorus trichloride. It can also be prepared by the reaction of phosphorus with thionyl chloride, SOCl2. When phosphorus is made to react with thionyl chloride, let me write P first to start with. Before balancing, let me start with P. Actually, it exists as P4. When phosphorus is made to react with thionyl chloride, it forms phosphorus trichloride, sulfur monochloride, S2Cl2. S2Cl2 is sulfur monochloride, and oxygen will go in the form of sulfur dioxide. Now, how to balance the equation? Can be 3, 2. So, it cannot be in the form of 3, therefore, we put 2, at least 2. 2PCl3. 2PCl3 means 6 plus 2, 8. If it is 8, it can be 4. Alright? 4SOCl2. If it is made to 4 sulfur, 4 oxygen, equation is balanced. Alright? It is balanced equation. But we used to write P4. Except phosphorus, everything is balanced now. If we make P4, everything has to be multiplied by 2. Because it is 2. Earlier, it can be like this. 2P plus 4SO2 gives 2PCl3, S2Cl2, 2SO2. But when we write P4, the rest should be multiplied by 2. Therefore, 8, 4, 2, and 4. So, phosphorus reacts with thionyl chloride to give phosphorus trichloride, sulfur monochloride, and sulfur dioxide. So, phosphorus trichloride may be prepared by these methods. What is the importance of phosphorus? That is, properties of phosphorus. When we talk about properties, mainly it undergoes hydrolysis to give phosphorus acid. Trichloride gives phosphorus acid or orthophosphorus acid. H3PO3 may be called as phosphorus acid or orthophosphorus acid. That you will be getting during hydrolysis. 3-chlorine will become 3HCl and phosphorus will become as 3PO3. Alright, instead of 3-chlorine, 3OH. Instead of 3-chlorine, 3OH. Water is made of hydrogen and OH. 3 hydrogen and 3 OH. And 3 OH will replace 3-chlorine. 3-chlorine get combined with 3 hydrogen to become 3HCl. So that is about the reaction of phosphorus trichloride with water, that is hydrolysis. But actually, the reaction proceeds in a different manner. PCl3, when made to react with water, what is happening? The water molecule is making coordination bond with PCl3, the d orbital of phosphorus. Phosphorus in the outermost energy level has got 3s2, 3p3 is the electronic configuration. 3s2, 3p3, d orbital will be vacant. D orbital will be vacant. 3, 4, and 5. So this is the electronic configuration for phosphorus 3s, 3p, 3d. It has 2 electrons here, 1 electron here, 1 electron here, 1 electron. D electron will be vacant, and into those d orbital, water molecule is making bond, and we will be getting a molecule like this. PCl3 dot H2 I can write. It loses a HCl molecule. It loses HCl because during hydrolysis HCl is being eliminated. HCl will be eliminated. 1 HCl. Remaining will be added in the form of OH. So I can write P OH Cl2. P OH Cl2. Only one OH group is replaces 1 chlorine. Hydrogen combined with chlorine to become HCl. So this is how it is being formed. Alright. In the next step, the POHCl2, which can otherwise be represented as HPOCl2. HPOCl2. I can write the same thing. What we have written, PCl3 with PCl3, one water molecule get coordinated to give PCl3 dot H2O. After that, elimination of HCl. Therefore, this hydroxyl group considered to replace one chlorine, POH twice. POH Cl2. With this POH Cl2, one more molecule of H2O is added. So that what will happen? Another chlorine will be replaced like this. Again, addition of water, and then another chlorine will be replaced by OH. You will be getting POH twice Cl plus a Cl, which can otherwise be written as HPOCl2 plus H2O. One more hydroxide replaces chlorine. Therefore, I have to add one hydrogen, one oxygen. H2PO2. Why? One more OH added. H2PO2. One chlorine get reduced plus HCl. So same thing is written in different pattern. Am I correct? And then with this H2PO2Cl, yet another water molecule is added. Again, what will happen? The Cl will be replaced by OH. So I can write H3PO3. That chlorine taken up by hydrogen to become HCl. So this is how the reaction goes. Instead of writing POH, I have written this way so that I will be getting H3PO3. Alright. So in each step, in the first step, one chlorine is replaced by one OH. Second step, second chlorine is replaced by one OH. Third step, another chlorine is replaced by one OH. You will be getting H3PO3. So 3 chlorine atoms are being replaced by 3 hydroxyl groups. This is how, by the hydrolysis, we get phosphorus acid. Alright. Now, second important reaction is chlorinating reaction. These are the 2 important reactions of PCl3. Second reaction, chlorination. Chlorination, in one aspect, chlorinating metal. Here, the hydroxyl group is replaced by chlorine. How? Whenever we have compounds containing OH group, C2H5OH, ethyl alcohol, CS3COH, acetic acid, ethanoic acid, CS3CH2COH, propanoic acid. When these compounds are made to react with PCl5, already you might have studied under alcohols or acids, the OH will be replaced by PCl3. We are studying reaction of PCl3. All the 3 chlorine atoms are replaced by 3 OH, just here, like here. 3 OH comes over here, 3 chlorine get combined to become 3 HCl. The exactly same manner. Here water is considered as 3H and 3 OH. Likewise here also 3 molecules. 3 molecules. 3 ethyl and 3 OH. 3 acetyl and 3 OH. 3 propanyl and 3 OH. And instead of 3 OH, 3 chlorine will be replacing. You will be getting 3 C2H5Cl plus H3PO3. Same thing, H3PO3 plus 3 HCl. 3 hydrogen with 3 chlorine. 3 ethyl with 3 chlorine, that's all. 3 acetyl with 3 chlorine. Therefore, 3 CS3COCl plus H3PO3, POH thrice. 3 CH3CH2COCl plus H3PO3, POH thrice. Alright? Ethyl alcohol, ethyl chloride. Ethanol, chloroethane. Acetic acid or ethanoic acid. Acetyl chloride or ethanol chloride. Propionic acid, propionyl chloride. Or propanoic acid, propanyl chloride. Propionic acid is common name. Propanoic acid, IUPAC name. You will be getting propionyl chloride or propanyl chloride. Likewise here, ethanoic acid, ethanyl chloride. Acetic acid, acetyl chloride. Ethyl alcohol, ethyl chloride. Ethanol, chloroethane. So that is about chemical properties of PCl3. What is the use then? It is used as a chlorinating agent. It is used in the preparation of phosphorus acid, that's all, nothing else. Then regarding structure, phosphorus, we have seen the electronic configuration 3s2, 3p3. This is the electronic configuration of phosphorus. It undergoes hybridization to give sp3 hybridization. one s orbital and 3 p orbitals get combined, 3s2, 3p3. 1s orbital, 3p orbitals get combined to give 4 equally energized orbitals. Into that, electrons are filled like this. Therefore, phosphorus in the outermost energy level has got 3 singly filled orbitals, 1 lone pair. So, 1 lone pair will be at the top. These 3 orbitals, these 3 sp3 hybridized orbitals with single electron overlap with 3 chlorine, p orbital of chlorine, thereby giving bond like this: phosphorus, chlorine, 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 and a lone pair. It is said to be trigonal pyramidal. 3 chlorine atoms are occupying corners of a triangle, and above that a lone pair or a phosphorus projecting like this. Trigonal pyramidal. And for PCL3, the bond distance between phosphorus and chlorine is found to be 214 picometer. Here, approximately it is little bit 204 picometer. 204 picometer. And in phosphine we have seen the bond is a little bit lower. I think it is 142 picometer. 142 picometer in phosphine. Phosphine also similar type of structure we have seen. Here the bond distance is found to be 142. Probably hydrogen being smaller, and therefore the bond length will be shorter. sp3 and the p orbital overlap here. Here sp3 and s orbital overlap. And therefore the bond length between phosphorus and hydrogen is a little bit lower. Moreover, the angle CL-PCl angle is also somewhat lower. It is 102, half of this value you can remember, 102 degrees. Whereas in phosphine we have seen 93.5 here. 93.5 here, 102. Why that much difference? Here, because of bulkier group of chlorine and due to sp3 and p orbital overlap, usually we say the bond pair repulsion will be higher. So it will try to compress the bond pair of electrons. But since Cl seems to be bulkier, actually it has to be 109 degrees 28 minutes. It is because of the lone pair repulsion, it is reduced to 102. Here it is much reduced. Here it is reduced only to 102 degrees. So in PCL3, PCl bond length is 204, unlike phosphorus hydrogen. It is 102 in PCL3, unlike here in phosphine 93.5. Both you can compare. All right. Thank you.